Imagine a world where you can effortlessly command machines and robots with simple hand waves or nods. No matter if you're jogging through the park, cruising down the highway, or even battling the unpredictable swells of the ocean. That's the revolutionary promise of this groundbreaking wearable technology. But here's where it gets tricky. Traditional systems falter in the chaos of real life, leaving us tethered to still, controlled environments. Intrigued? Let's dive deeper into how engineers at the University of California, San Diego are changing the game. A team from UC San Diego has crafted an innovative wearable system that empowers users to operate machines using natural, everyday gestures, even amidst intense movement like sprinting, vehicle travel, or turbulent seas. This cutting-edge tech, detailed in a paper published in Nature Sensors, accessible at https://www.nature.com/articles/S44460-025-00001-3, merges flexible stretchable electronics. Think of them as bendy, skin-like sensors that don't crack under strain, with advanced artificial intelligence. Together, they tackle a persistent hurdle in wearable technology, ensuring gesture signals remain accurate and reliable in unpredictable, real-world settings where motion can introduce all sorts of interference. The study, titled A Noise-Tolerant Human-Machine Interface Based on Deep Learning-Enhanced Wearable Sensors, highlights why this breakthrough matters. To clarify for beginners, wearable devices equipped with gesture sensors perform well when you're stationary, like typing at a desk. But as soon as you start moving, say waving your arms while walking, the sensors pick up extra noise from body motions, vibrations, or environmental disturbances, which jumbles the signals and makes control unreliable. This has historically restricted their use in daily activities, limiting practicality. But here's the part most people miss. This new system flips the script by embedding AI to filter out that noise in real time. As co-first author Xiangjun Chen, a postdoctoral researcher in the ISO Yufeng Li Family Department of Chemical and Nanoengineering at UC San Diego's Jacobs School of Engineering, explains, our system overcomes this limitation. By integrating AI to clean noisy sensor data in real time, the technology enables everyday gestures to reliably control machines, even in highly dynamic environments. In simpler terms, it's like having a smart assistant that separates the wheat from the chaff in your sensor data, ensuring commands come through clear and true. Now, let's talk applications. This tech isn't just cool. It's transformative for industries and everyday folks alike. For instance, it could empower rehabilitation patients or those with mobility challenges to guide robotic aids using instinctive gestures, bypassing the need for precise finger movements that might be difficult or impossible. Picture someone recovering from a stroke effortlessly directing a robotic helper to fetch an item with a simple arm swing, rather than fiddling with buttons. In industrial settings, workers or emergency responders might operate tools and drones hands-free in risky, moving environments, like controlling a robotic arm on a swaying oil rig without losing focus. And for underwater adventurers, divers could manage submersible robots amid churning waves, opening doors to safer, more efficient exploration. Even in consumer gadgets, imagine gaming controllers or smart home devices that respond flawlessly to gestures during a lively workout session or a bumpy car ride, making interactions more intuitive and less frustrating. This project stemmed from collaboration between the labs of Professors Shang Su and Joseph Wang, both from the ISO Yufeng Li Family Department of Chemical and Nanoengineering at UC San Diego's Jacobs School of Engineering. What sets this apart is its ability to handle a broad spectrum of motion disruptions, aligning seamlessly with natural human movements, something no other wearable human-machine interface has achieved reliably before. Under the hood, the device is a flexible electronic patch attached to a fabric armband, packing motion sensors, muscle detectors, a Bluetooth processor, and a bendable battery into a sleek, layered design. It's trained on a rich dataset blending authentic gestures with varied conditions, from jogging and tremors to oceanic swells. When you make a gesture, the system captures arm signals, runs them through a custom deep learning algorithm that eliminates distractions, decodes the intent, and instantly sends a command to, say, a robotic arm. As Chen notes, this advancement brings us closer to intuitive and robust human-machine interfaces that can be deployed in daily life. Testing proved rigorous, Participants controlled a robotic arm while running, under strong vibrations, and in mixed disruptions. It even underwent validation in simulated ocean scenarios at UC San Diego's Scripps Institution of Oceanography using their Scripps Ocean Atmosphere Research Simulator, mimicking lab-created and actual sea motions. Across the board, it delivered precise, quick responses with minimal delay. Looking beyond the specifics, this innovation sprang from a vision to aid military divers in commanding underwater robots, but the team discovered that motion interference plagues wearable tech universally, not just beneath the waves. It's a widespread issue that has historically capped system reliability in routine scenarios. This work establishes a new method for noise tolerance in wearable sensors. Chen adds. It paves the way for next-generation wearable systems that are not only stretchable and wireless, but also capable of learning from complex environments and individual users. For beginners, this means future devices could adapt to your unique style, like personalizing a fitness tracker that learns your jogging habits to avoid false triggers. Co-first authors include UC San Diego researchers Xiangjuan Chen, Ziyuan Liu, Xiaoxiang Gao, and Liu Yin. For more details, check out the full paper, Xiangjuan Chen et al., a noise-tolerant human-machine interface based on deep learning-enhanced wearable sensors. Nature Sensors, 2025.
2. 10038 S44460025 0000013 https://dx.2.org/10.103.8 S4446 liniuță 025 liniuță 00001 liniuță 3.
But here's where it gets controversial. While this tech promises greater accessibility and efficiency, critics might argue it's another step toward over-reliance on machines, potentially distancing us from direct human interaction. Is empowering gesture controls in dynamic environments a boon for inclusivity, or does it risk simplifying complex tasks too much, leading to skill erosion? And what about privacy concerns? Could these AI-enhanced sensors inadvertently track more than just gestures, sparking debates on data security in wearable devices? Do you see this as a game-changer for everyday life, or worry it might widen the divide between tech-savvy users and others? Share your thoughts in the comments. Do you agree with the potential, or disagree with any implications? Let's discuss. Citation: Wearable tech lets users control machines and robots while on the move. 2025, November 18th. Retrieved November 18th, 2025 from https://techexplore.com/news/2025-11-wearable-tech-users-machines-robots. HTML. This document is subject to copyright. Apart from any fair dealing for the purpose of private study or research, no part may be reproduced without the written permission. The content is provided for information purposes only.